Okay, so let's get started. It's already 3 minutes past 5. So we have. Can I request all the kids to keep the videos on? Because otherwise I might go wrong with my name call out. I see Thiru is here, Pirana is here, Ayai is here, Dikshita, Saurya, and Nihan. Alright, so what did we learn in the last class? Who all remembers it? Yep.
Like the type of transformation of shapes, like dilation, transformation.
Okay. Ipsa, what do you remember to talk?
Oh yeah, the dilation.
Okay. So we learned about geometric transformation. That is where we talked about two types of transformation. One is called rigid transformation, where the shape doesn't change, it just moves. And as part of that, we learned about translation, rotation,
Reflection.
and reflection. And then we talked about non-rigid transformation, that is where the shape was changing. Everybody is okay with the temperature inside? Yeah, okay. When we talked about non-rigid transformation, that is where we saw that the shape is changing, meaning it's scaling up or scaling down. Okay? And let's look at what are we going to learn today. But before I move on, anybody having any questions with respect to whatever we have done in the previous classes, or you guys don't want to talk about it? Nobody wants to talk about it? Okay, all right. So let me quickly call out the topics that we are going to learn between today and tomorrow. If we have time, we'll pick up something more also tomorrow. But let's. So the topics that we are going to cover are congruence and congruence using rigid transformation. And then we will talk about equivalent ratios of similar shapes. So we'll talk about congruence using transformation, and then equivalent ratios of similar shapes. Tasvik, what is happening with Tasvik? He is joining in, joining out, joining in, joining out. That's what is happening. So let's quickly check one more time. Saurya has joined in between, Swari has also joined. Arihan also has joined. Okay, so let me first ask you guys, what do you remember or know about congruence? That's the first question I have. Advik and Arav, I will not ask you because you guys have heard about it from me. We have talked about theorem of congruence also. So new kids, yes, Ipsa.
Congruence is when something's the same.
Something is the same. Okay, anybody on the screen? Is anybody on the screen wanting to explain what is the simplest way to interpret the word congruence? Congruence. Very loaded word for somebody who is not as good with English as you guys. Okay. Yes, Dikshita.
And if you have a triangle, like it has same length, same properties.
Exactly. Anything that you guys want to add?
It means equal.
Yeah.
Congruence, we have the prefix.
Why is style is needed? Tell me now.
So congruence means like same. Like,
Congruence is a replacement for the word same.
like a square.
Congruence is not limited to square. Congruence could be even for
Notebooks.
any shape, any object that we want to talk about.
Drum.
Okay, now don't keep talking in between, otherwise my chain of thought will get interrupted. So here, congruence simply means same or a copy of something. Okay? So if I ever say two things are congruent, I'm essentially saying they're exact copy of each other. Yeah? Is that agreeable? Now, in geometry, there is nothing called exact copy. Geometry has its own way of looking at things. If you say these two triangles are same, geometry, there's an animal called geometry which will be confused. What do you mean by same? Geometry knows every shape by its property. So if I'm looking at a triangle, these two as two triangles, then this triangle has certain properties which are three sides. This triangle has certain properties which are its three sides. This triangle has three angles. This triangle also has three angles. So these are the properties of these two shapes. That's the only way geometry recognizes anything. So in geometry world, if you dare to say that these two shapes are congruent, you are essentially saying they have each and every property matching. Pick up one side, there's a matching side, other side. Pick up the second side, there's a matching side. Pick up the third side, there's a matching side. Pick up one angle, there's a matching angle. Pick up another angle, there's a matching angle. Likewise. Yeah. So I know I'm stretching this discussion, but I want to make sure that people, many times when I explain the kids that what is similar? They say they are the same. No, there is no similar, same with same. Similar and same are different. I look somewhat similar to Amitabh Bachchan. I will claim that. People will say you are joking. I still have the luxury of saying so because I did not say I look exactly same as Amitabh Bachchan. Similar. I also have two eyes. He also has two eyes. See, that is the matching aspect. Similar is like when you have that, when you want to leverage the benefit of doubt. There is something that you can still say okay, partly, little bit. I also have a nose. He also has a nose, kind of thing. Okay. So similar is when you have that luxury of or some tolerance. Congruence doesn't have that. Okay? Same doesn't have it. So congruence is a replica for or replacement for same. Similar, not same. Is that okay, everybody? Everybody okay so far? And you guys heard the joke of the millennium, a teacher claiming that he looks similar to Amitabh Bachchan, and you guys were giggling about it. Yeah? Yes, sorry. You saying something?
I am saying anything.
Okay. So similar and same are not the same. Okay? That's weak. Yeah.
Oh, so is there a sign to like there's a congruence?
Take it easy for now. We'll come to that. Okay. When we go deep into congruence, when we talk about the theorems of congruence, we'll talk about it. But right now we're just touching the surface of it, where we are saying that what is congruence and how does it play a role with respect to transformation. That's the goal. Is everybody so far okay with me? I hope everybody has excused me for me claiming I look like Amitabh Bachchan, but let's move on. Okay? That was the joke of the millennium. Let's move on. Alright. So, and good that I said Amitabh Bachchan. I still have a chance to survive. If I would have claimed Rajnikant, the die-hard Rajnikant fans would have literally thrashed me to the worst possible extent I could imagine. Okay, coming back to this one question, the class. So now let's imagine congruence with respect to transformation. So transformation, we talked about two types of transformation, right? Reflection, rotation and translation.
And dilation.
That is the rigid part of it. And non-rigid part is when you are changing the dimensions. So we will not use the dilation from a congruence standpoint. When you talk about congruence, meaning your dimensions are not changing. Okay? So congruence and translation we will use very carefully. We will only use certain types of translation when the shape's dimensions are not changing. Okay? So when we are talking about translation, now again it might look like a debate, but we'll go for it. Let's say I have two triangles here, okay? This is 5 centimeter, 6 centimeter, this is 7 centimeter, okay? This is 5 centimeter, this is 6 centimeter, this is 7 centimeter. I'm just making it up. Yeah, it's okay. So I have these two triangles. And if you look at these two triangles, okay, I'm saying that what exactly do you see with respect to these two triangles right now? I mean, I have done something to get this table from here to here.
Reflection.
What else?
Rotation.
Yeah, rotation.
No. Again, let me simplify this question for you. You see this triangle here and you see this triangle here. Tell me, what are the observations you guys have made so far by looking at these two triangles?
The second one, like it's upside down. It's like,
Upside down, okay. What is your observation?
I was gonna say upside down.
They both have like congruent sides because if you flip that over, then it will have the same dimensions.
Okay, let's see what Nihan says.
They all have matching angles and the other is upside down.
Okay. Anybody else?
Oh, I mean sides, not angles. Side.
Okay, Thiru.
It's just like rotating 180 degrees. One of the there's
Okay. What else? I can literally write an essay on what I'm seeing right now. You guys are just concluding it with a line or two. No, your chance is over. There are other kids also in the class. Let's see. Okay. Aryahi, Deekshita, Swari. Guys, don't be shy. Hiranya, Abhi, and
say the same thing as everyone else.
everyone else. That means you are not leveraging your opportunity well. Let's see what Abhi has to say. Yes, Abhi.
they both have the same angles.
Okay, now be ready to get tortured by my essay. Ashita, do you want to ask something, beta? What is your observation by seeing those two triangles? Hiranya, want to add something, beta? Tasvik. Now hear my story. Sangeeta, you have been quiet today. Why so? Add some more spice to the story. Yes, Sangeeta.
If it was rotation, I think the 7 and the 5 are flipped around the sidelines.
Okay. Alright, so here's my story. Hi Sami. So, what we are seeing, the first observation we have by looking at this is, this one has 5, 6 and 7 as 3 sides. This one also has 5, 6 and 7 as 3 sides. So, two triangles with matching dimension will be congruent. Okay? They are congruent for sure. That is one observation. Now, second thing is, this triangle from here to here, it has gone through certain transformation. And those transformations are, one is reflection. So this is reflected across this x-axis, that is one. Second is, you are seeing a translation also. So first it is reflected and then it is translated. Meaning it moved from here to here. So you observe the behavior of congruence. This is a first observation was, this is a rigid transformation where the dimensions have not changed. And if there are two triangles, with matching sides, they are congruent. There is a theorem of congruence that you all would be knowing about. SSS.
Wait,
Done?
side, side,
You
side.
control the emotions, that's very important. Let's not get carried away with only the emotional side of things. So first thing was, when you saw these two triangles, you saw that they have matching dimensions, so they are congruent. And then from here to here, this has gone through multiple transformation. One is reflection across the x-axis, and then another reflection maybe, or just a translation, depending on whether you see sides between flips. Now let's Advik, Arav here. See, imagine, visualize this. When I'm reflecting this, this will remain 6 and this 5 will come here and this 7 will come here. So, once I reflected it across the x-axis, it came here and then I just translated it here. It just moved from here to here. Imagine a case where this side was not 7, this side was 5 and this side was 7. Then you were not seeing just reflection and translation. You were seeing 2 rounds of reflection actually. So when you move it here and then you translate, its sides are not matching. So here this time it's again reflected. So 5 comes to this side, 7 remains this side. So there is a lot of visual element to it that, guys, for next 40 minutes, let's control our emotions and make sure that we are only doing what we are supposed to do. Okay? But question to everybody, are you guys seeing merit in what I am trying to convey here? Is it making sense to everybody or not? Okay? So many likes. I don't get this many likes on my video, but I am getting a lot of likes here. That's good. Alright. Coming back to the point that I was trying to mention was, when you have a situation where you are trying to decode by looking at the geometrical shapes or the information that you have, you can relate that with different concepts that you are aware of. Okay? So, there might be a situation, okay, let me not mix too many things, we'll look at some problems one by one. So, when you have information, you can relate that with all the concepts that we are aware of, and then we can look at how do you transform that information for making a conclusion out of it. So just by looking at this picture and this picture, many of you said that it's just reflected. These two triangles are congruent. But there was much more to the story, saying, okay, these two triangles have matching sides, so they are congruent. Then apart from being, so basically from here to here, it's a transformation. What a transformation it has gone through, then you looked at reflection and then translation. So let's look at some more problems. I think that will relate to these concepts and we'll be able to appreciate these concepts a little bit better. So let's look at one more example actually. Let me draw something here. Ashita, Hiranya, are you guys with me, beta? Thiru, Nihan, everybody? Sorry? Yeah. Okay, now this is a circle, okay? And this is my circle A and this is my circle B. So what is that you see? Let's say this is the coordinate plane XY. From A to B, how would you describe this journey? What has happened as steps to get from A to B?
It decreased with a scale factor of like 1/3.
Okay. Sanvita, 1/3? Are not funny at all.
Approximately
Hold
1/3.
it. Okay, let's hear Sanvita's point of view also.
It got dilated
it was dilated. Okay. What else?
It got small stuff.
Okay. So dilation is again, dilation we talk about, like we discussed in the previous class, it could be either scale down or scale up. So when you see the dimension changing, obviously it's dilated. That is one. So it becomes smaller. What else? Go ahead. See, I claim that I am Amitabh Bachchan and you are showing me all the stunts of Amitabh Bachchan.
So basically, I can see that the A circle increased by like a certain percentage of B. So if you could calculate like the unit rate.
I'm saying, tell me the journey from A to B. What are the things that you are saying?
It could be reduced by like a certain percentage to match the.
Saying which
certain-
percentage?
It could be approximately like 30.
I don't care. I have not given you guys enough information to even make a guess around it. So again, math is all about data. Now look at this story, okay? You will, from A to B, we are seeing two forms of transformation. Yes, we do.
Never mind.
We are seeing two forms of transformation. One is, it has dilated. Obviously, it became, let's say if here it would have become this small, it became smaller by a scale factor. And then translation also happened. Right? It moved by, the center moved from here to here. So it moved by this many points on x-axis and this many points on the y-axis. Yeah? So we are just relating this one, that when you have a situation to look at, you can always see what has happened to your dimension. If dimension has changed, you are talking about non-rigid transformation. If your dimension has not changed, then you are talking about only rigid transformation. Okay? So to mark these words, the change in dimension and then change in position. So dimension, position, these are two things that you would take into consideration, okay, to make your judgment. Now, all this was the theory part of it. We have to look at how does it apply to real math problem that you would actually want to solve. Let me put some real problems for you guys to deal with. Now, there's somebody called Jordan dilated quadrilateral ABCD to create quadrilateral PQRS. This was 107.9. This is PQRS. 107.9, 94.9, Y 83.2. Okay? And then this is PQRS. So Jordan dilated quadrilateral ABCD to get to PQRS. So let's draw ABCD. Okay? It doesn't look similar.
I have a question.
Wait, my question is not done. You're asking me question.
This is the teacher.
Okay, don't go by my drawing. Go by the data. Okay.
This is my science teacher. This is the principal.
Okay. So now I'm reading the question. Okay. Jordan dilated quadrilateral ABCD to get to PQRS. Which proportion must be true?
So we define X and Y.
Yeah, you're very smart. I'm so proud.
You have to find out X divided by Y.
Ooh. Really fun.
X.
So I'll just see. The information that we have from the question is, this is your quadrilateral, where the dimension, this is A, B, C, D. This is dilated. And again, from a clue point of view, what I'm saying is, it's similar, right? It's zoomed in, zoom out. That's what we're talking about. Dilated. So you have to find out the value. Let me keep it simple for you guys. Find out the value of x and find out the value of y. It is dilated from ABCD to PQRS and there are the dimensions given to us. You have to find out what is the value of x, which is this side, and find out the value of y, which is this side. And this has come from this guy. So ABCD was dilated. As you can clearly see, it is scaled up to get to PQRS. Try finding out the value of x and y. Yes, Sanjita.
Can you read the side lengths one more time?
Okay, so AB is 64. BC is 38. C to D is 73. A to D, I don't know. Okay, that is X, you have to find it out.
It's not impossible.
P to Q is 83.2. Q to R, I don't know, that you have to find out, which is Y. R to S is 94.9 and P to S is 107.9. So,
Like, this was like my notebook since like.
I don't really care about it much. I want you to use your energy for solving this problem.
Yes, sir. I mean,
Everybody clear? It's dilated from here to here. And as you can see, this is scaled up. So I want you guys to find out value of x and y.
yes, sir.
Is everybody clear about how you're going to approach this, or
Yes, sir.
there are doubts in mind? Like Tasvik is chewing his nails to figure out what to do. No, it's okay with that. I'm just checking how everybody is approaching this. How about Saurya, Sami?
My.
Okay, don't worry about it. This is easy part. Okay, we'll deal with it. You see again. I'm giving you guys that the freedom to do some scribbling, to think about it. Okay, there'll be many a times you'll come across problems that you would have not seen before. Read the problem and see if you can think about it. Many times, when you think, you will get some clue or some direction. Okay, just try it. Going right around doesn't matter. Yeah.
Wait, what is KB? It has 64.
Yeah.
That looks like a 6Y.
1y is enough. 64. That's why I was reading it also for everybody.
Yes, sir. I'm a very good reader.
What happened to Ariyahi? Ariyahi is very quiet today.
I hope it's sick, sir.
I'm sorry, Beta?
I'm sick.
You're still sick? Okay.
I hope you feel better, Ola.
Guys,
You're so welcome.
don't get emotional about things. Solve this problem. This is more stressing thing. You cannot prescribe a medicine to Ariyahi. She'll have to see a doctor only. That's the only way she can get better.
I'm in true doctor.
Ariyahi. Arab. Focus on it.
Is P to S on the right side? Is that 107.9?
Yeah, this is 107.9.
I'm ready to learn.
Swari, Saurya, and Thiru. Are you guys trying it?
Yeah, I'm trying to solve it.
Okay.
Yes.
I'll give you guys 2 more minutes, okay? Yeah, tell me.
So, this question is kind of.
Okay, I am not going to entertain any question of yours. You are putting zero effort for solving it.
Right.
I don't care about all the drawings you have done. Solve this problem first.
Wait, is SR 94.9?
Even if it's 24.9, solve it better. Do something. God is getting really sad.
I thought that was a god math. Android often is not acceptable.
See, now we have IPSA also in the class, right? You guys making unnecessary sound will get her also distracted. So be respectful and mindful of what you do.
Yes, sir. Wait, 38.
Dikshita, are you trying better?
Yes,
Okay.
did I use the restroom?
100%.
This question is impossible.
What?
Guys, I'm not interested in anybody's sense of humor. Solve this problem first.
Wait, how much more time do we have?
What have you done so far?
I mean, like, I'm trying to find like the.
Solve it, and only solve it.
I promise I'll solve it. I'm a very good listener.
Right.
Bro, that is first time hearing that.
Advik, you focus on yours better. Arav, you focus on your work. Otherwise, I'll unnecessarily get emotional, okay?
Shush, let me stop.
So did you try some interesting creative ways to try solving it? Sammy, did you try some creative ways to solve it? Alright. Alright, Nihan, Hiranya, anybody? Okay. I'll give you guys 2 more minutes, okay? I have few more problems that I want to solve in this class. At least one more after this one. So I'll not listen to anybody after 5:40, 5:36 right now. Done?
Uh-huh.
Okay. Do yourself first.
I'm
For
so sorry.
X, I got 94.8.
Oh, God. I'm trying to make calculations.
And for Y, it's 56.49.
Okay. Now, whatever you have done. Okay, Advik, doesn't matter. What he's doing is for him. Whatever you have done, if I ever get to look into this, I will hardly understand anything. I would want you guys to get used to the way of solving problem like story, like I always do on the board.
Okay.
So I'm not only preaching, I practice also. So when you're trying to solve it, do that solution approach step by step so that while everybody else is doing it, at least you have a way to explain that as a story. Okay?
I sort of understand this.
What is that?
I sort of understand that later.
Your understanding is doesn't help. Your question paper will go to somebody who will give you marks, right? So again, for you guys, you are dealing with MCQs.
I'm so
MQC. MCQ only, right?
I
No,
know what that is.
Multiple choice question. That's it.
Oh,
You guys, don't have to solve it and then show it. In our days, we used to solve the problems and then people will see it. So that way, they will see the process also. I mean, even if your answer doesn't match and if you have done 80% of it correct, you'll still get marks.
Oh, partial marks.
So anyways, doesn't matter. Do that story thing. Otherwise, that scribbling doesn't give me any confidence.
Okay.
You want to fight? For confidence?
Arif, give me a high five for doing the thing. Solve this. Okay.
Number 1.
I'm feeling proud. I'm so sorry, teacher.
Arif, not interesting. Solve this. Sorry, Samita, anybody? Nobody's done yet? Hard to believe.
I know what to do.
Uh-huh.
I just can't do it right now.
Okay. Now, give yourself, I'm giving you guys 1 more minute, okay? After that, I will jump onto it. Alright, what is your plan?
Oh. I mean, like, so. I mean.
No, see, when I asked that question, I was saying that you have to have your own plan. Why are you just looking at this thing and hoping that something will be done? It will not work.
I promise I'm very reliant on myself. I'll
Why? It's not an interesting thing, Riku. Solve this problem first.
This is kind of difficult right now. I'm trying to lock in.
Wait, if the decimal's too long, can I round it?
Yeah, that's okay. As long as you can narrate your own story, I'm fine.
Sorry, teacher. Can you please pass the water? I live in harsh conditions.
Okay, done. Everybody done.
Done deal.
Arif,
Grab the water.
Arif, this is the 8th my bad that I've heard in the last 20 minutes.
Oh.
9th one. Okay, so let's come to this one. This is Advik. That extra sound effect is not needed. Come back to this question. So, everybody here, can I have everybody's attention please? So, we have these two quadrilaterals. And the question says, ABCD is dilated to get PQRS. And don't go by my drawing skills. I have kind of messed up the drawing a little bit. But, good thing is, it says A, B, C, D. The sequence is A to B, B to C, C to D, D to A. Is P, Q, R, S. Okay? So, if you are starting from A here, you are starting from P here.
Oh, shoot.
So, AB and PQ. BC and QR. CD and RS. So, you can write it down, okay? A, B, C, D here. P, Q, R, S. Okay? AB, PQ, BC, QR, CD, RS. And there will be one more, that will be DA and SP. Why I'm doing this one is just to make sure that you know which side is exploding or shrinking to become what side. Okay?
Yes, sir.
So here, when you are dilating something, you are talking about similar shapes only. So look at this. AB became PQ. AB became PQ. BC became QR. CD became RS. DA or AD became SP.
Oh,
Yes, sir.
screw the drawing. Was that how was?
So again, when you're talking about dilation, you're talking about something zooming in, zooming out. By how many, by what scale factor you are expanding it or shrinking it?
Yes, sir.
Yeah? So here, what is AB? Look at this AB. AB is given as 64. I'll replace AB by 64. Is equal to PQ. PQ, what is PQ? 83.2. BC. BC is given as 38. Put 38 here. Is equal to this QR. QR is Y. We have to find out. CD is here 73. RS is this one 94.9. DA.
X.
D to A is X.
X.
SP.
107.9.
S to P, 107.9. Now, if you have to find out Y, take this combination. If you have to find out X, take this combination.
Wait, but you did something else. You just wrote the thing down. Yes.
My job is to navigate you guys to the step where there is no unknown.
Yes, sir. That's not funny.
Sami, did it make sense, beta? No, not much. Guys, all your laughter, all your emotions are to be controlled.
I'm trying to control. He's trying to.
No, so but again, try not to entertain things which gets you distracted, okay? I also do crack jokes just to get everybody's focus back, not to disturb the class. Come back here. So Sami, here, what I was saying was, this question says, this shape ABCD is dilated to become PQRS, meaning either it is expanded or squeezed. When you look at this one, so basically it's expanding. When you are dilating, you're just talking about similar shapes. You're not changing the dimension, you're not making a rectangle look like a circle or a circle becoming a trapezoid for us. The shape will remain same, it will become from a small shape to big shape or vice versa. So that means the size will grow in the same proportion. Let's say if this is dilated by scale factor 2, meaning it is made 2 times bigger or half the size. Yeah? Dilated by 2 meaning it became 2 times its size. If it's dilated by scale factor half, that means it became half of the original size. Yeah? Meaning every side will become half. Every side will become twice of original side. Now when you have similar similar shapes, meaning their sides will, all the sides will grow in the same ratio. Meaning if AB grew from 64 to 83.2, this is the scale factor by which this side grew from AB to PQ. Okay? So the other side will also grow by the same factor, that's what I'm saying. So what we did was, AB became what? PQ. BC became what? QR. CD became what? RS. DA became what? PS. So that's what we repainted here. And there were 2 unknowns. This X was not known, AD length was not given, and QR length was not given. We said, okay, I don't care about it. Since we know that this guy dilated to become this, every side became, AB became PQ, BC became QR. So we put that ratio and then whatever value we have, we just plug it here. Does it sound okay?
Yes, sir. It sounds perfect, crystal clear.
Yeah?
Clear as gold.
Yes, Sami. Clear, beta?
Yeah.
Take a deep breath. Control your emotions. Promise yourself that okay, this is something I'm doing, it's not right. No, not only here. See, I'm not trying to be mad or anything. I'm telling you this will help. Because even in a much more serious setup, here for me you guys are like kids. imagine you doing the same thing in a college. Will that be acceptable? No. You might get suspended for a few classes if you don't know. Yeah? In a class. I mean, that's possible. So I'm teaching, I mean, see, I have gone through the same phase, right? I was not born at this age, 50-year-old, right? I was born like a toddler and then I grew up. So we all have our emotions to control. When you go in a more serious setup, you'll have to learn how to control it. Because otherwise it might hurt, which you don't want to go, right? So that's what I'm telling you guys. So don't get me wrong that I'm just mad and I'm venting it out. Not the case. I'm teaching you guys what I have gone through and how probably I have learned how to control it. I'm not saying that you guys have to lose your personality and be serious all the time, but when you know how to control it, learning driving is very important. But knowing when to apply the brake is more important. That's what I'm teaching. Okay? Alright? Everybody okay? Saurya, Samrita, sorry, Thiru. I'm sorry. Yeah, somebody was saying something. Arihan. Yeah, okay. So, now the summary of this is very simple. Whenever you're talking about dilation, you're talking about similarity concept. Meaning, when you are dilating by a scale factor of 3, that means every side of the shape becomes 3 times bigger. If you are dilating something by a scale factor of 0.2, that means every side of the original shape becomes 0.2 times of its original size. Yeah? So, if I am talking about a triangle, a rectangle, or any other quadrilateral or heptagon, octagon, whatever, you don't have to get stressed out by looking at the complexity of the shape. You will only bother about what is becoming what and what is my scale factor. Yeah? Does that sound okay? Yeah? Let's look at one more problem and see if that is actually a problem or not. So, this is A, B, C, D, E. Okay, this is 32, this is 58, this is 4040, this is 64, this is 84, and this is the shape. This is P, Q, R, S, T, and this is given 24, this is 63, this is 48, this is 30, and this is given as Y. Now I'm reading the question for you guys. Pentagons ABCDE is similar to pentagon LM and PQ. ABCDE is similar to the pentagon PQRST. Sorry, what did I do? Okay, yeah. It was starting from somewhere else. That's why I was reading it wrong. It is L, M, N, P, Q. Yeah. I used the wrong letters. So the pentagon ABCD is similar to the pentagon LM and PQ. And the dimensions are given. Which proportion could we use to find out the length of NP? This one, Y. And we are given 4 options.
Is that the only side that's missing?
That's what it looks like. Equal to 24 by Y Option B is 40 over 64 equal to 24 by y. 24 by y. Option C is 24 over 32 equal to y over 64. And option D is 24 over 32, who is singing to create the chorus, y over 40. So here, again I am repeating the question. ABCD, a pentagon ABCDE is similar to the pentagon LM and PQ, hands down. Your talking is not very important. Let me complete it. And the dimensions given are AB is 64, BC is 40, CD is 58, DE is 52, 32, and E to A is given as 84. And this in this pentagon LM and PQ, this is given as 48, this is given as 38, 30, this is Y, which we have to find out, this is 24, this is 63. And it says which of the proportion represents, or we can use to find out the length of N to P. And these are 4 options. Now, yeah, tell me, what is that you were trying to say?
I got 4.46 y. For like,
Did you hear the question carefully?
yeah.
What does the question says? The question says these two are similar pentagons and the dimensions are given. It says which of these options help you find out N to P, which is Y. Yeah? Everybody heard the question? Deal with it. So I'll be quiet for next 3 minutes. Yes, Sanita.
Can you read like the sidelines one more time?
So A to B is 64, B to C is 40, C to D is 58, D to E is 32, and E to A is 84.
Oh, is it reflected?
It's not saying reflected, it's saying they are similar to it.
Oh,
So this pentagon is similar to this one.
okay, so C to B equal to P to Q?
So it's like it's starting from A, B, C, D, E. It says L, M, N, P, Q.
Oh,
So you can use the same sequence basically.
alright.
Yes, Sanita, saying something? You got the answer? I mean, you got the information?
Oh yeah, I just forgot to put my hand up.
Okay. So raising hand is not important. Solving it is more important. I'm assuming everybody is trying, right? Sorry, Thiru, Dishita, Nihan, Arihan, Sami, Samita, everybody is trying, right?
Yes, sir.
Okay. Okay. What's happening, Abhi?
I took another box.
Okay. Is everybody trying? Arihan. Tasvik, too much of emojis. I don't need that many. I need only one answer. A or B or C or D. Okay, so it's almost time.
I see the little one.
Wait, how do you answer?
The answer is he didn't say the sauce that you've drawn.
No. It's this.
Right? Okay, so now let's look at it. It should be, see, it's a, yeah.
I got A.
You also got A. So everybody here, see, when you have a problem like this, it's about how do you break it down. So what I was saying, A, B, C, D, E, L, M, N, P, Q. You have to find out N to P. N to P aligns with which one? This is first side, second side, third side. If you start from here, first side, second side, third side. So 58, if you pick this side, this thing, 58 by Y. 58 by Y is 58 by Y. This is one option, okay? 58 by Y. I'm picking up the third side by Y. Look at all the options where you'll get 58 by Y. This is the only option where when you move 58 to this side, it will become 58 by Y, and that will be equal to 32 by 24. This guy comes here and this guy goes here. 32 by 24. Now let's see if 32 by 24 is the right combination. 32 in this side is my first, second, third and fourth side. What is the fourth side here? First, second, third and fourth side. 32 by 24. Fourth side by fourth side is equal to third side by third side. If that doesn't sound okay, you can always go with the most simple approach.
So
You will say AB by LM, the first side, equal to BC by MN is equal to third side NP by, what am I doing?
you're reversing
CD by NP equal to DE by PQ equal to EA by QL. Now you plug in all the values. AB by LM. AB is 64 by LM is 48. BC is 40. MN is 30. CD is 58. NP is Y. DE is 32. PQ is 24. EA is 84. QL is 63. Now look at all the options. What you are seeing is, see, 32 by 58 equals 24 by Y. So you are looking at 32, 24, 58 Y combination. This is your combination. Yeah? And then, see, since you have Y here, Y and 58 on the other side, so you will bring 58 here, move 24 here. So it becomes 24 by Y equal to 32 by 58. That is this answer. So again, you guys must be thinking that no, we could have had some intelligent way of doing it. I think we don't need to be intelligent. It's okay. Less intelligence is also okay, workable sometimes. But what I'm insisting on here is the only thing that we need to carry with us is when we are talking about similarity, each and every side of my shape changes by the same common factor. and that is what is represented by this factor. Which side became what side? Which side became what side? Which side became what side? And they'll change by the same ratio, because when you are squeezing or expanding, you are squeezing or expanding by a scale factor, and that scale factor is this ratio. This AB grew from AB to LM from 64 to 48. That is the scale factor by which it has changed. Is everybody able to make sense out of whatever I said?
Yes, sir.
Then I think you have all the valid reasons to meet tomorrow. Alright? Yeah. Bye bye. Bye bye. Take care. Bye bye. Bye bye. Good night.